Okay, and get set up from current slide. And let's go over a few announcements. There are a few out there. I've seen some. I know there's others out there. If any of you are at all interested in summer research opportunities, lots of four-year schools, universities, apply through the National Science Foundation, and quite a few of them run programs, National Science Foundation sponsored programs for undergraduates to do research. It's a great opportunity, gives you a good application of what you've been learning in the class. It's usually, some are as short as 1 to 3 weeks. Most of them are more like 10 weeks. So it takes up most of your summer. And so, is it Mel? No. Huh? Womack, got it. Kiara. Okay. Sorry. So I believe they post them somewhere on Blackboard or on someplace else on the website. So check those out. I've got one paper in my other classroom. If any of you are interested, it's one at UAB. Sounds really like a very positive thing. It covers lots of different majors. So if you're interested, stop by, and the classroom, that's where I go right after this class, and I'll let you just see that one. Now, a little bit closer to home, I've been asking this for weeks. Has anyone seen anything about student course evaluations? Yesterday. That's what I was going to say. Finally, they sent out something yesterday. Last week of class. So the students in my classes yesterday hadn't seen them, but I'm glad y'all saw them. So please do the student course evaluations. Those are, I'm a department chair, math department chair, and when I do evaluations on my instructors, that's one of the biggest inputs that I have. I don't really care what kind of front they put on in front of me. I want to know how they look to the students. So I look and pay close attention to student course evaluation. Of course, if you don't respond, and they have 3 students responding in a class, actually that's too few, 5 or 7 or 8 or something, is that all that respond? Those may be the few students who really like the instructor and they got really high marks, or they could be a few that are really griping about it and they get really low marks, and neither one of them are very fair to the instructor. So please, folks, do your student course evaluations. Like I said, it's one of the best things I use to evaluate my instructors and to talk about what kind of job they're doing and that type of thing. Also, usually when you do those, has anyone done them yet? Usually when you do them, there'll be 1 or 2 others that pop up, something like registration process, food services, library, housekeeping, something like that. Please do those too. See, I get feedback from you every day that we're in here, whether you know it or not. You know, I read your faces and that kind of stuff. Sometimes it's hard. No, I'm just kidding. And you talk to me, you know, some do anyway. So anyway, I get some feedback. These people and these other things hardly ever get any feedback because they don't see you day after day, week after week. They only see you once or twice. So this is a great way for them to see how they're doing their jobs. So please do the student course evaluations and do them soon. They usually keep them open till after finals are over. But if you're anything like I was as an undergraduate, I'm not saying that you would be, but as soon as that term ended, do y'all ever remember the little game Etch-a-Sketch? That you did that and then you turn it over and shake it and everything disappeared? As soon as that last exam was over with, someone shook my brain and it all disappeared, you know. So it was I wouldn't remember to do a course evaluation. If you're better than that, you can wait till the end. Otherwise, try to do it sooner, okay, so while you're remembering. Okay. Now, let's talk about this class. We have class today and class Wednesday, Thursday, day you've been dreading all term, the last day of class. I know it's going to be hard to get over, but try to. So on Thursday, day after tomorrow, Thursday, I'm going to return every paper that's in this stack, except the research papers. Oh, let me talk about research papers for a moment. I got one today. I felt so pleased. That now keeps us less than half of you have turned in your research papers, okay? You got one class left, okay? I thought Thanksgiving break was a great time to get those things done, okay? One came in. I'm glad to have it, okay? Please get those in. Yes?
Am I able to finish the test we did last class, Thursday after class?
Thursday after class? Yeah, if you could do it sooner, that would be better.
Are you going to be on this campus tomorrow?
I'll be on this campus all day tomorrow up until 4 o'clock. Okay? I have office hours from 8 to 10 in the morning, and that's about it for office hours. But you can catch me in class, between classes, or things like that. Yeah.
What day is that exam?
I'm sorry?
What day is that exam?
Okay, I can't hear.
What day is our exam?
Oh, okay. Yeah, well, I'm getting to that one. Thanks for asking. Okay. All right. So please get your research papers in by Thursday, last day. After that, you start losing points. Okay? I will accept them late, but you'll be losing points. So please get them in by Thursday. Get all of your quizzes and tests in and completed by Thursday, because I'm going to be returning these. That's why I hesitate to say after class, because they'll be out there then. And that's not fair to the people who did them on time. So please get these completed before Thursday morning, 8:30, because I'll be returning these then. Now, okay, what we're going to do today and Thursday is continue in chapter 3. We'll get as far as we can in chapter 3, and then your final exam will the final exam is Tuesday morning. Now, I haven't seen the schedule, but what they've done the last few terms, for some reason, even though about a year or two ago, they moved all the classes to start from 8 o'clock to 8:30. Everything got moved back half an hour. Everybody was so pleased to do it. And then when it came final exam time, they moved it back to 8 o'clock. So I think I haven't seen it for this time, but the way they've done it ever since they changed the time is still have exams starting at 8. So the exam for this class is 8 o'clock Tuesday morning, 1 week from today. Okay? And the exam will consist of 2 parts. A very short test on chapter 3, just covering just what we cover in class from now till today and Thursday. That's all it's going to cover. Very short. Won't take you more than 15, 30 minutes to do it. And then the comprehensive final will cover everything from chapters 1 and 2. I probably won't include 3 because I'm going to test you on 3 then. And that test will be about the same length of the test you just did, the chapter 2 test. 10 questions approximately, multiple parts, okay? But 10 questions, probably 5 from chapter 1, 5 from chapter 2, okay? And hopefully you can do that within an hour, so you'll have plenty of time. You got an hour and 50 minutes, and I don't think any of you have any problems with time, but if you do, I'm here all week, okay? So I'll be on this campus. I'll be on this campus Monday, but that's before the test. But Tuesday I'll be on this campus from 8 o'clock in the morning until 8 o'clock in the evening. Okay, Tuesday. Wednesday I'll be on this campus, as I answered before, from 8 o'clock in the morning until 4 o'clock in the afternoon. Then I go to the Birmingham West campus for a physics class or test. Okay? Then on Thursday, 8 to 8 again. So you got plenty of time. Yes?
So you said 8, not 8:30, right? 8.
The exam is scheduled to start at 8. Now, on Tuesday. Yeah. Let me got to get my eyes back on here.
Well, we
I'm sorry?
Will we be able to use our pages, like our little station?
Yeah, formula and equation sheet, perfectly fine for chapter 3 test and for the final exam. Absolutely. Yeah, you can have 2. Yes. Okay. In fact, if you have the ones you had for the chapter 1 test and test 2, and you want to use those again, you can have 3 then. Yeah. But if you didn't keep those, try to keep it to 1 page. I used to know where everybody was in here, and now, oh, there you are. There's Kenny. Okay. So, all right. You can have formula and equation sheets for the chapter 3 test and the final. Chapter 3 test is going to be very short, okay? And then for the final exam, you can have either the 2 you did before or make up a new one. Actually, making up a new one makes it fresher in your mind. You know, you're not just passively doing active. Yes.
So the chapter 3 and the 1 and 2 tests, are they graded as the final?
No. The chapter 3 test counts as a test, and then the final counts as a test. Yeah. Okay. Chapter 3 test is one of those tests that, you know, if your quiz average is better than the lowest test score, that counts as one of those. Should be, with such a short test on what we're just covering now, you should do quite well on that, so you may be able to replace a lower test score, okay? Then the final exam cannot be dropped, so everybody has to take the final. Okay, so if you haven't done one of the quizzes or tests, I've got to have them completed before Thursday morning, okay? I'll be here at 8 o'clock Thursday morning, so you have 30 minutes before class starts. Yes?
You said the final is only on chapter 1 and 2, right?
1, 2, yeah. The chapter 3 test will cover 3, so we'll just be 1 and 2. Okay. All right. Any other questions on that? All right. For those who came in a little later, please do your student course evaluations. They finally opened them yesterday. I don't know what took them so long. I've been asking for 2 or 3 weeks. Where are the student course evaluations? So, all right. Any other questions before we get going today? Make sure the projector works today. Okay. No questions? Yeah, here we go. Now, we're on chapter 3, exponential and logarithmic functions. 3.1 are exponential functions and their graphs. We just got started on page 198 before we ran out of time last time. We're just below the definition of an exponential function. Okay. Now, exponential function, let me move back and show that definition one more time. Here's a definition of exponential function. Exponential function f with a base a is denoted by f of x is equal to a raised to the x power. Okay? Unlike a polynomial function where your x was the base and your power was an integer. Or a radical function where x was the base and some fractional form was the power. But they were always numbers. Now, the base is a number, the exponent is your variable. So that's the difference between exponential functions. Now, notice here they say, a is always positive, but never 1. So it could be 0.3, 0.005, okay? Any positive number except 1. 0.9999, fine. 1.0001, fine, okay? But not 1, okay? Greater than 0, but not equal to 1. X can be any real number. That's just not whole numbers. It's just not integers. It's just not rational numbers. It can be any real number. Rational, irrational, positive, negative, fraction, decimal, whatever. Okay. Now, the base a is equal to 1 is excluded because, what if you did that? F of x is equal to 1 to the x. Well, no matter what you put in there for x, that would be 1. So there's your function. You know, it's just 1. Always 1. Never varies. Not very interesting function, okay? That's a constant function, not an exponential function, okay? Now, you have evaluated x a to the x for integer values of x, yeah? 7 raised to the 4th power is 7 times 7 times 7 times 7. We know what that is. We've even done it for rational values. 7 to the 3/2 power would be 7 cubed, and then take the square root of that. We've done that, okay? Those are rational values of x. So you know that, for instance, 4 cubed is 64. That's 4 times 4 is 16 times 4 is 64. 4 to the 1/2, that's 4 raised to the 1st power, which is just 4, but then the square root of 4, because this is the index of the radical, the square root of 4 is 2. Okay? Now, you might say, why is that not plus or minus 2? Well, we won't get into that now, but right now we'll just leave that as 2. However, to evaluate 4 to the x for any real number x, you need to interpret forms with irrational exponents. Okay? Those can happen. There's no way you can do this in your head. Okay? I don't think. If you can, you got a way better head than I do. So, for instance, a raised to the square root of 2, where the square root of 2 is an irrational number, that means it goes on forever and ever and ever and never repeats any pattern at all. So it can't be expressed as a ratio of 2 numbers. If it could, yeah, we could calculate it. Okay? So what you do, if you're having to do this as a number, you approximate this for the purpose of this text, sufficient to think of that as a number that has successively closer approximations. You can first do a to the 1.4. You can do that. Okay? A to the 1.41, a to the 1.414, a to the 1.4142, a to the 1.41421. You can keep going as far as you like. You're never going to get it exactly, but those approximations will get closer and closer. Finally, you can't do any better. Now this was, I don't know why they put this in here, because most of you have calculators, and your calculator you can find the power key of the exponential key, the a to the x key, and then press, well, it depends on the syntax of your calculator, but you can actually put for the x the square root of 2. And actually what your calculator will do, it will use some approximation out here. Probably this is 1, 2, 3, 4, 5, 6, 7, 8, 9, probably 10 or 11, 12 digits. And then it'll stop, because that's going to get you close enough to anything you can see on your screen. So you can do this with your calculator. You don't have to go through this technique. But, because guess what? You're going to use the same technique here. You're going to do a to the x, and then you'll do 1.4. Yeah. So it's no different putting an irrational number than a rational number. Okay? But that's the idea. Okay. So I hope everybody has a calculator today. So use a calculator to evaluate each of these values. 2 raised to the negative 3.1 power. Okay? I'm going to tell you approximately what that will be. 2 to the minus 3 would be 1 over 2 cubed, which is 1/8. So this is going to be something a little bit less than, or maybe a little bit greater than 1/8. So around 0.125. And Tyler is here. Tyler number 1, if I can find you. There you are. Tyler Kaiser. Okay. Now. Yes.
Do you have to have a scientific calculator to do this?
What's that?
Do you have to have a scientific calculator to do this?
What kind do you have?
Just a little regular number.
Okay, but what kind of functions does it have? Oh, your phone?
Just the regular,
Okay.
basic calculator.
Okay. don't have an exponential key on here.
So you probably need a scientific calculator.
That would probably be a good idea. Most of your phones are equipped for this too, so you can use your phone. I'm sorry? Okay. Now it's not X to the N. Okay. Gotta find it on here. It's not X to the N. It's not that. Those are the X no. It's like that one, only it can be A to the X. This is E to the X, 10 to the X. Let's try it, huh? Oh, there we go. There, I'm sorry. Yeah, this key. So you do 2, and then here's the exponential key. 2 to the, and then you put in negative 3.1. See what you get. Sorry, I just did some fancy. Glad you're here. Okay, for those who don't have an A to the X key, some of the older calculators have that. Let me get Amari here before I forget it. Okay. Has anyone else come in since I called roll? For those who have come in recently, that didn't hear me say it before, they have finally opened student course evaluations. So please do those. Please don't forget to do those. Okay, for those who do not have an A to the X key, and for some reason my computer has gotten so it's not wanting to stay lit, okay, then you can use this key. I mean, this is the key that you use. For this, it would be 2. If you got an A to the X key, use that one. If you don't, you do 2, then the caret key, okay? That's the one that looks like a housetop, okay? Mountaintop, something like that. And then you do your negative 3.1, okay? Now, about your negatives. Some of the older calculators, scientific calculators even, have, you would type in 3.1 first, and if you see a plus minus key, something like that, plus minus key, you have to enter the number first, then hit this key. If you have a little bit more modern calculator, you look for the key that has the minus sign in parentheses. Do not use the subtraction key. That's not the right key. That's for subtraction purposes. This is the negation key. If you have this key, you press that first and then 3.1. If you have this key, you do the 3.1, then press that key and that negates it. So you have to know your own calculator. So don't come into the test. And by the way, for those who did come in later, the final exam is 1 week from today, starting at 8 in the morning. Now, I started to say this before, and I kept having questions. I forgot to say it. If it's going to be really difficult for you to get here at 8 because you have kids and you got to schedule, you're on the bus schedule, whatever, and you just can't get here at 8, get here as soon as you can. As I said before, I'm going to be here all day Tuesday. I'll be here from 8 in the morning until 8 in the evening, okay? Now, we'll have a class 1:15 to, it goes 1:15 to 5:45, but we're not going to go that late that day. All we got to do in that class that day is have a lab and a test. So that's probably not going to take more than 2 to 3 hours. So, but that's right down the hall at 255. You can come in there. You can come in my office, anywhere. I'm either going to be here in the morning, my office after that, when I'm in class 255, then back in my office. So I'll be here all day long Tuesday. So if you can't make it by 8, get here as soon as you can. If you have another final, go take your other final, come back and finish that one. Okay? And then, like I said before, Wednesday I'm here from 8 until 4. At 4 o'clock I have to go to the Birmingham West Campus for the physics final. Then on Thursday I'm here from 8 till 8 again, okay? That day all I have is the final exam at 1 o'clock. So and that won't last very long. They'll be done well before an hour, I think, okay? So, did everybody get this punched in? What kind of answer did you get? Say it a little louder. 0.1.
Yeah, 1669.
1269?
1.
Oh, one. Okay. 0.11. Say again. 62. Okay. My hearing is terrible. 0.1162 blah 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 blah. Okay. Now, most of the time in real life, if all you have are 2 digits here, 2 digits will be sufficient here. The book doesn't abide by that, but most scientists do. So 1.12 would be a fine answer. But 1.116, like I said, it's a little bit less than 1/8. 1/8 is 0.125. So sounds like a reasonable answer. Okay, how about this one? F of x is equal to 2 to the negative x, but your x here is pi. Okay? Now, get your calculators. Have a calculator for the test next Tuesday. Please don't come in with no calculator because you're going to have to be doing this kind of thing. So that would be 2, and if you don't have a to the x key or something like that on your calculator, then look for the caret key, 2 to the caret, and then you put negative pi. And again, how you do your negation depends on your calculator. Hopefully your calculator will have a pi key, yes.
I just wanted to say on my phone I figured out that key is a y to the x.
Y to the x, that's perfectly fine. A to the x, y to the x, something like that, okay? That is the key that shows up on some of the calculator screens. See, I can't teach calculators because everybody has a different one. You have different phone apps and things like this, so you have to learn your own. But if you don't have one of those keys, this will work. Now again, your negation, if you have this key, you press that and then the pi key. If you have this key, you press the pi key first and then press the plus or minus sign. Do not use the subtraction key, okay? That is not, I'm going to go back to red here, and it's not the subtraction key. It's the negation key, which is 1 in parentheses, or the plus minus key, okay? Guess what? This answer is not going to be very far from that one, because pi is 3.1416, blah, 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 and that's not very far from that. So this will be 0.1. Anyone get it? 1 is what you say? 3, 2, 3, blah, 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 blah. Okay. Huh? What is that again? Is that it? 1.1132? 3 what? Okay, whatever it is. Okay, you get the general idea. Again, it's not far from this because pi is very close to 3.1. Yeah, it's 3.14. So since the denominator gets a little bit bigger, this number gets a little smaller. So yeah, that's fine. All right, this one's quite different. You're a different base. This time you have 0.6, and you're raising that to the 3/2 power. Now you could then put in 3/2. Just to make it easier, I'd put in 1.5 because I can divide 3 by 2 and get 1.5. But if you can't, you can. Here's what I suggest if you did 3/2. Do 0.6 raised to the open parentheses 3 divided by 2. If you don't do that, it will first cube this, and then the answer is going to divide by 2. So if you put them in parentheses, it'll do the whole thing. That's why I say If I can do that in my head, I'm going to change that to 1.5 and that'll be fine. What kind of answer you get there? Again, a pretty small answer, isn't it? What is it?
0.46.
4, 6? 4? Blah, blah, blah. All right? Something like that. Okay? How did the book do? Oh, look at that. They did pretty well. They got, on the first one, 0.11662. Why didn't you give me the right answer? Okay, you probably said it. I can't understand it. And then the next one was 0.1133147, and the last one was 0.46477580. Okay. So if I were going to round that, and I would have rounded that to 0.465 because that 7 bumps it up one. All right. Does that make sense? I'm sorry? Well, you can't put all the digits, so wherever you stop, always look to the right, see what the next digit is. If it's a 5 or greater, you bump the last digit up by 1. If it's 4 or less, just drop it. Okay. So yeah, round. But you know, if you're close enough, you're going to get credit for it. Okay. All right. Any questions on those? Let's see how they did it. And that's exactly what they show here in the book. You do the base first, 2. If you have one of those other keys, X, Y to the X, A to the X, something like that, press that key. If you don't, use the caret key, and then use the negation key. Now, if you don't have the negation key, but have the plus minus key, wait and do the 3.1, then plus minus, okay? You have to know your own calculator, then press enter, and that's what you get. If you don't get that, please let me know, and I'll try to help you figure it out. Or ask a neighbor, because y'all know your calculator is probably better than I do. Any questions? And F of pi, where F is 2 to the minus x. This would be 2 caret negation key pi, and you get almost the same answer. Very, very close. Okay? Because pi is close to 3.1. Okay? And then F, the 3/2, and they showed it exactly like I said the second time. You can enter 0.6. Now notice, they always write it in the book as 0.6, which is fine. When you do it on the calculator, you don't have to put a 0.6. You do it, fine. But if you want to save yourself a stroke, it's 0.6, caret. And then, because you have a fractional form here, open parentheses, do 3 divided by 2, close parentheses, enter. Otherwise, if you left out this parentheses, it would be 6 raised to the 3rd power. It's going to do that first, and then it's going to divide that answer by 2. That's not what you want it to do. So anytime you have an expression like this, you see exponents take precedence over multiplication and division. Remember, please excuse my dear Aunt Sally, whatever she did, okay? The exponents always take precedence over multiplication and division, okay? So that's why you put these in parentheses to do that first, then you raise it. Or, like I said, just make it 1.5, and then you save yourself some keystrokes. I'm cheap. I'm lazy. Really lazy. Okay. All right. Any questions on those? All right. Surprise, surprise. This book likes to do graphs. Okay. Graphs of exponential functions. On the same coordinate plane, sketch the graph of each function. 2 to the x and 4 to the x. Okay? So I'm going to do the graph here. And guess what I just did? I didn't leave much room for negatives here, did I? I'm going to give you a hint. Exponential functions are always positive. Okay? Always positive. Now, if you had a minus sign in front of here, that was going to flip it over and make it negated. But I didn't have any minus signs there, so this is going to be positive. Okay? I probably should have moved my y-axis some, so I think I'll do that. Okay? And extend the x a little bit and make the y here. Okay? Now, let's tick off a few points here. Don't need that one, but I'll put it in. Okay. Now, I'm going to be lazy again. I'm going to set up my chart here. I'm going to put the x's here, and then I'm going to put f of x here, which is 2 to the x. I'll put g of x here. Oh, let's do it in a different color. What color you want g to be? Somebody, huh?
Orange.
Orange. Aren't you glad you chose orange? Okay. Let me erase g and make it orange. Okay. G of x. Can you read that okay? 4 to the x. Okay? So, I'll be a cheerleader here and say, give me an x. Whoops, that's not what I want to do. Give me an x. Give me a bunch of x's. 1, 2, 3, 4. You stuck on positive numbers. Go negative. Second? 0. Negative 1. Okay, we'll stop there because I'm running out of room. Okay, so we're going to use those x's here, and evaluate our f of x, okay, which is 2 to the x. So you can do this in your head. What's 2 to the first power? 2. What's 2 to the second power? 4. What's 2 to the third power? Someone say 8? Good, okay. 2 to the fourth power. Ooh. Huh? 16, excellent. How about 2 to the 0th power? Second? I couldn't hear. I can't hear. No! 2 to the 0th power. Anything to the 0th power is 1. Okay. Now, what does it mean to be 2 to the minus 1 power? What is that? 2 to the minus 1. What does that mean? 2 to the minus 1. That's what? It's 1 over 2. 1 over 2 to the first power. And, of course, that's 1/2, which I'm going to put 0.5. Because, okay? What's 2 to the second power? Negative 2 power. I think I will go back. I'll make that 1/2. Okay, this one will be, you know what 2 squared is? 4, so this is 1 over 4. And what's 2 to the minus 3? 1 over 8. Okay, that's easier to do that way. All right, let's do our 4s. Orange. Aren't you glad? Okay, what's 4 to the first power? 4. 4 to the second power? 16. 4 to the third power? 64. 4 to the fourth power? 128. Listen to that rattle off. Okay, 4 to the 0th power? 1. 4 to the minus 1 power? 1 over 4. 4 to the minus 2 power? 1 over 16. And 4 to the minus 3 power? 1 over 64. Okay. All right. Let's plot our... You want to do the G's while I've got the orange up here? Okay, let's do it. So x equal 1. Y is equal to 4. 1, 2, 3, 4. There is the first point. Okay. X equal 2. Y is equal to 16. 1, 2, 3, 4, 5, 6, 7, 8, 9. Nowhere close. We're off scale already. Okay. So let's go on down to when x is 0, what is your G? 1. When x is minus 1, what is your G? 1/4. That would be down here somewhere. When x is minus 2, it's 1 over 16, which is way down here somewhere. When x is minus 3, it's 1 over 64, which is barely more than 0. But guess what? It never reaches 0. It gets closer and closer and closer, never reaches it. But when it gets here, it starts going up, and it goes up like crazy. Okay? There is your g of x. Okay? Now let's go back and do f of x and notice any differences. Okay? Your f of x, when x equal 1, f is 2. Okay? 1, 2. Buckle my shoe. Okay? When x is 2, f is 4. So it's up here. Okay? When x is 3, f is 8, right? Something about like there. When x is 4, f is 16, way off scale. Okay? When x is 0, what is f? 1. When x is minus 1, what is f? 1/2. When it's x is minus 2, f is 1/4. When x is minus 3, x is 1/8, which is something about somewhere down there. Okay. So this is also going to 0, but not as fast as the other one is. But then when it reaches here, it starts going up, and it goes up, and it goes up, and up, and up, and up, and up. Okay? So that's what's happening. The larger the x on the right-hand side, the more rapidly it goes up. And look at these exponential functions take off very rapidly. But on the left-hand side, when x is smaller, it goes down gradually. When x is larger, it goes down really fast. But they never go to 0. They're always positive, slightly positive, but still positive. Never 0. Never negative. And they all go through 0, 1. If it's a pure function like that. Okay? Now you can't have translations and all that kind of stuff. That's true. You can't have reflections, then they go negative. Okay? But this is how it goes. Does that make sense? Yay or nay?
Yes.
All right. Good deal. Let's see how the book does it. Oh, look at that. They didn't use pretty colors like you did. They go as high as 16 here. So f of x is 2 to the x. 1, 2, 1, 4. They left off 8. 8 is at 2, and 16 is at 4, at 3. Wait, no, I'm looking at the wrong one. Okay, here we go. To the x. It's 1, 2, 4. 8 would be here, and 16 would be here. X to the 4. 4 to the x, now they did theirs horizontally, I did mine vertically, it doesn't really matter, however you like to do it. When you do 4, then it's 1, 4, 16, just taking off like crazy. Coming this way though, they crisscross there at 0, 1, and the 2 to the x stays above the 4 to the x. So 4 to the x falls off really quickly. 1 over 4, 1 over 16, 1 over 64. Whereas 2 to the x is 1 over 2, 1 over 4, 1 over 8. Now, they're close enough together, you can't tell the difference in them. But the 2 to the x is below 4 to the x when you're positive x's, negative x's, 2 to the x is above 4 to the x. So 4 to the x is falling off very, very quickly. Does that make sense? Okay, good deal. Any questions? Okay. Now, other things to notice. Both of these graphs are always increasing. Always increasing, meaning monotonic, which means they also are what else? 1-to-1 functions, because they're always increasing. Or always decreasing will also be 1-to-1 functions. So that means these functions have an, if it's 1-to-1 function, it always has an, say again? A what? Okay, it's close to that, not quite. Inverse. 1-to-1 functions always have inverses. Okay, we'll try to get to that later. Okay, so both graphs are increasing. However, the graph of 4 to the x is increasing more rapidly to the right. Okay, actually it's increasing more rapidly everywhere. Down here it's lower than the other and increasing more rapidly here, and then certainly increasing more rapidly there. Okay, and the graph of alpha of x equals 2 to the x. Okay. So the following summarizes the basic characteristics of the exponential functions. Now, they're showing 2 of them now. They haven't done this one yet. We did do this one. In the basic, okay. They're getting several things in it. Graph of y is equal to a to the x when a is greater than 1. Okay? Remember we said a was always greater than 0 but not equal to 1. Well, that's 1 is a dividing point. You can either be greater than 1 or less than 1, between 0 and 1. So we're going to take the a's greater than 1. Okay? The domain, all real numbers. Okay? The range, only positive numbers. They're never negative. Now, notice 0 is not included, so you have a parentheses in front of the 0. So it's never 0, only positive. Okay? The y-intercept, 0, 1. Just about always. Okay? And this is a strictly increasing function. If a is greater than 1, it's an increasing function. And the x-axis is a horizontal asymptote as x goes to, a to x goes to 0, as x goes to negative infinity. Now notice this is a both-sided horizontal asymptote. It's only on the negative side. It's also two things, smooth and continuous function. No gaps, no breaks, nothing. Smooth, continuous function that goes on forever. Forever in this direction, forever in that direction. And it goes up incredibly fast. Okay. Goes down very, very slowly here. Okay. Now, that's for a greater than 1. Okay? The next one we're going to look at, again with a greater than 1, but this time a to the minus x. Okay, this time, these are everything inverted. You know, as x is increasing, then that is 1 over a to the x. That's what this means. So therefore, again, your domain is all real numbers. Your range is still 0 to 1, not counting 0. Y-intercept is still 0, 1. There is no x-intercept because it never touches the x-axis. But now it's a decreasing function. Strictly decreasing, always decreasing. Okay? Which means it's also 1-to-1 functions, exactly. Okay? So it does have an inverse also. The x-axis is a horizontal asymptote, this time for positive x's. X is approaching positive infinity. It's also a smooth and continuous function. Okay. Notice the graph of the exponential function is either always increasing if this is a is greater than 1, and this is a positive exponent. It's always decreasing if a is greater than 1, and that's a negative exponent. Okay? So it never changes direction. I mean, all of them are 1-to-1 functions. Okay? Now, what they didn't do is show you what happens when a is between 0 and 1. We'll do that a little bit later. Now, because they're strictly increasing or strictly decreasing functions, that makes them one-to-one functions, right? That means they do have inverses. Well, no, I'm sorry. I jumped ahead. Because they're one-to-one functions, they pass the horizontal line test. Remember the horizontal line test? That horizontal line can only cross once. If they're strictly decreasing or strictly increasing, the horizontal lines are only going to cross once. Now, sure, horizontal line at y is equal to 0 would never cross because it never gets there. It gets close to it. It's an asymptote, but it's not a thing. But anything greater than that is only going to cross once. Okay? So it's a one-to-one property. So therefore, if they're one-to-one, for a greater than 0 but not equal to 1, if a to the x is equal to a to the y, that means x has to equal y. Because those are one-to-one functions, and if the y's are the same, well, not the y's, the functions are the same, the inputs have to be the same. So that's what the one-to-one property tells you. And that gives us a pretty easy way to calculate some stuff, okay? Oh, I just noticed. They skipped example 3, okay? And we almost did it. But back here where we did example 2, let's do example 3. I'm going to erase example 2. And how are we doing on time? Did I remember to bring my watch? I think I did. Yes. Oh, we got time. Okay, good. All right. This time, example 3 is going to be capital F of x is equal to the minus x, and capital G of x is equal to 4 to the minus x. Okay? So we're just slightly changing our functions, but it's going to make a big difference. Okay? I think you probably already have figured out what's going to happen, so let's tick off a few points. Whoops. Okay. Now, I'm going to set up my t-table, but it's no longer a t-table, but whatever you want to call it. We'll put x's here. We'll put capital F of x here, which is 2 to the minus x, and we'll put what color you want G of x to be this time? Anybody? Second? Green. Okay, G for green. I like it. Okay. Whoa, it didn't take, did it? Okay. Let's do green again. Okay. So G of x, which is 4 to the minus x. Okay. Let's give me a bunch of x's. Wait one, let me get my pen set up again. Okay, yeah. Say again? Say again? -2, -1, 0, 1, 2. Let's go and do 3. We got room for it. We may do -3 too, just because we have room for that too. So I'll throw that in for fun. All right. So what is F when it's 2 to the minus x? So this would be 2 to the minus 2. What's minus a minus? Plus. So 2 to the plus 2 is, y'all know that, 2 to the second power? 4. Sorry. 2 to the minus 1, well, minus a minus is plus again. 2 to the 1 is 2. 2 to the 0th. Oh, how about minus 0? Still 1. Okay, that's a dumb question. Okay, when x is equal to 1. 2 to the minus 1 is 1/2. 2 to the minus 2. 1/4. 2 to the minus 3. 1/8. And 2 to the minus, 2 to the minus of minus 3, which is 2 to the cubed, is 8. Okay, I just threw that in there. All right, let's do our green, G. 4 to the minus of minus 2. Minus of minus 2 is 2. 4 squared is what? 16. And 4 to the minus of minus 1. 4 to the first to the 1 is 4. 4 to the 0 is 1. 4 to the minus 1 is 1/4. Minus 2, 1/16. Minus 3, 1/64. And 2 to the minus of minus 3, which is 4 cubed, is 64. Okay, way off scale. All right, so let's plot. Let's go on and do the green ones first. When x equals minus 2, which is here, we're at, the G is 16. 1, 2, 3, 4, 5, 6, 7, 8, off scale. G to the minus 1, x is minus 1. You're up here at 1, 2, 3, 4. Okay? And at 1, at 0 is 1. At 1, it's 1/4. 1/16. 1/64. And going down. So guess what? Does exactly like we did before, except in reverse. It's reflection across the y-axis from what G to the 4th, little g, which is 4 to the x. It's just exactly across there. And let's do the same for F, which is black. Okay? When x equals minus 2, what's F? 4. Minus 3, I didn't do the minus 3 before because that was 64, way off scale. Minus 3, since we're over here, that would be 8, which I think is way up here. Okay? Wait, I got that wrong. To the minus 2, yeah, is 4. Yeah, minus 1 is 2, and then 0 here, and this was 8 up here. And then we'd be 1/2 here, 1/4 here, 1/8 here, and 1/16. Oh, I'm sorry, I went too far. Okay, it would be 1/16. So this one comes down like this. Again, they cross at 1. Whoops, they cross at 1. Now this one stays on top. Okay, so this is exactly what we saw. We missed example 3, but when we did this, not this one, we saw that's how it happened. When a to the minus x is going in that direction. Okay, strictly decreasing. Any questions about this? All right. Now, all we said about 1 to 1, we're ready for example 4. Whoa! They skipped example 4 as well, didn't they? Yeah, shame on them. Shame, shame. Okay. So we'll use this again. I'll erase everything we've got, and this time ignore all of that. Example 4. What if we have 9 is equal to 3 to the x plus 1? Now, remember what the 1 to 1 said? If a to the x is equal to a to the y, then that's if and only if x is equal to y. Okay? Now, here we don't have that, do we? We have a 9 as our base here, and we have a 3 as our base here. Now, is it easier to write 9 as a base 3, or write 3 as a base 9? 9 is a base 3. What is 9 if 3 was your base? What is 9? 3 squared, perfect, is equal to 3 to the x plus 1. Isn't that right? 3 squared is 9. Now we have same bases, right? And these are equal to each other. That means the exponents have to be equal. So that means that 2 is equal to x plus 1, right? And how do we solve that equation? That's a hard one, isn't it? You see how we got that? Okay. How to solve that equation? Second, subtract 1 from both sides, and that gives you 1 is equal to x. Perfect. So the solution for that is x equal 1. And of course it is. I mean, you can almost look at this and see. 9 is equal to 3 to the second power, and x plus 1 would be 2. X has to be 1. 1 plus 1 is 2. Oh, high level math today. 1 plus 1 is 2. Okay. So yeah, that is the correct answer. Plug it back in. 1 plus 1 is 2. 3 squared is 9. Perfect. Okay. Let's do one that's a little hairier than that. That's the B part. Sorry. 1/2 raised to the x power is equal to 8. Ew. Okay. How are we going to do this? Okay. If we could write A as a power of 1/2, 8 as a power of 1/2, how would that go? Well, what if we wrote this as 8 as 1 over 1 over 8? Isn't that 8? Agreed or not? Okay. Now, I don't know if that's helpful or not, but this would be 1/8 to the minus 1, wouldn't it? Yay or nay? Okay. Now, what if we wanted this 8 to be 2 to something? What would that be? 8 is 2 to what power? Third. So this would be 2 to the third power, and that's to the minus 1, right? Well, does that also mean this would be 1/2 to the minus 3 power? Sorry about that. Minus, ugly, ugly, ugly. Okay. Let's see if that's right. 1/2 to the minus 3, that would be 2 to the third. If you flip this over, you lose the minus sign, right? That would be 2 cubed, and that is indeed 8. So, we've done it. We've got the same base here. Now set the exponents equal to each other. What do you get? Exponent here is x equal, exponent here is -3. Is that right? Let's check it. Let's do 1/2 to the minus 3 and see what we get. Punch that in your calculator and see what you get. I would punch in 0.5 if I were you. 0.5 raised to the minus 3 power. What do you get? That gives you 8. That checks. We got it. Okay? Yes.
So you lost me.
Okay? Tell me where.
I don't know. How do you do 1 over 1 over 8?
Oh,
I didn't get
that stuff right there?
Yeah, like that, yeah.
Okay. Okay. All right. Okay. Let's do it the other way.
Yeah, it looks like it didn't.
Let's do 1 divided by 1/8. What is that? How do you divide fractional forms? 1 times 8 over 1, right? What's 1 times 8 over 1? 8. And this is exactly 1 divided by 1/8. So yeah, those are the same. Okay? Got it? Make sense? Okay. It's kind of a puzzle, okay? But it's a fun puzzle. Puzzles are fun, aren't they? By the way, there are checkpoints. As soon as you get out of class, do the checkpoints whenever you're not in another class. And if you can't get the answers, look at larsonprecalculus.com. We will start next time with top of page 201, example 5, which is also not on the slide set. So we'll do that. Okay. This one? That's 4, okay. I don't have it with me, but I'll get it in just a minute. Yeah. Okay. I'll, as soon as I can get this wrapped up. Okay? You have a few minutes? Okay, all right. Thanks. I'm sorry? Oh, sure. Okay. Let me turn off this light because it's blinding me. Okay. Oh, man. Okay. That's 2, right? Y'all gonna stay in here and do it? Okay. Okay. All right. The number you see there is as low as you could possibly go. You can only go up from there. Okay. And Reynolds ran 2, which is not. Lindsay is gone. Sorry. Okay. You want me to stick with this? Okay. I had it over the week of Thanksgiving, but it's all right. Yeah, it's all right.
Can I just see mine?
Okay. You need yours? Okay. You just want to see it.
Yes, please.
Huh?
Because you graded it up into this point, right?
I graded it up to a value. You had left off 1, so I didn't know if you were going to come back.
I gotta come back anyways to do the other one. I still not finished that.
Okay.
I wanna after they get their test, I wanna talk to them.
Okay. All right. Right. You don't want to see this. Okay. Anyone else?
I can take my test Thursday.
What's that?
I can take my test Thursday.
Okay. You need to go before class on Thursday. Class starts at 8:30, so I'm here at 8. Can you do it in 30 minutes?
Well, did you say?
I'll try if that's possible.
Okay.
Okay.
Okay. I'll be down in my office 265, 8 o'clock, maybe a little earlier.
Okay.
Well, before you go, did you not say that you would be here tomorrow
I'll be here.
until 4, as well as
I'll be here today until 8.
today?
I'll be here tomorrow until 4. Then I'll go to the Birmingham West Campus. I'll be on Thursday 8 to 8, and then Friday I'll be on the Birmingham. Oh, Friday I forgot to tell y'all this. I have a doctor's appointment at 9:20, so I'll be over there from 8 to about 8:40. Then I'll be at my doctor's appointment. I don't know how long it lasts. If it's through before noon, I'll go back to the Birmingham campus. But if it's not, I'll be heading home. Okay, so I won't be. You can't count on me except very early on Friday on the Birmingham campus.
Okay.
Okay.
I'll be here early Thursday.
Okay.
Okay.
Okay. All
All right.
right. Okay.
Here's mine. Thank you, sir.
Let me see. moving parts here. Okay. So, there you are. Huh?
I just want to see my grade.
I can't hear.
I just want to see my grade.
Oh, okay. Yeah, that's you. Okay.
I'll turn quiz two.
Quiz two, okay. And when do you want to take test two?
I could take it on later today.
Today? Later today or not right now?
Later today, because I have a class at
Okay. I'll be in my office until 11:30. I have class from 11:30 to 12:45. I'll be in my office from 12:45 until 3:15. I have a class that goes the rest of the day.
Okay, yeah, it's 12:45.
12:45-ish, okay. I'll be either in the classroom 2:55 or down in my office 2:65. Yes, all right. Lost you.
So Monday was 8 to 4. Do you have class
Okay,
tomorrow?
wait, let me, I don't put this in the right place, I'll use it. Okay, that's right, you're right.
Hi, I was gonna take my test today, but I realized that I left my quiz back home in Georgia. Is there any way I could get another copy of that, or if there's one online?
Okay, no, it's not online, but I can
I
get you
think
a
I
copy.
checked, I
think.
just needed another copy, because I can't drive 4 hours back.
Yeah, because someone would send you a picture of the
Yeah.
free copy.
Do you need graph paper?
No, it's okay, I have some. Thank you so
Okay.
much.
All right, and you get the test done before Thursday?
Yes, are people coming before, in the morning on Thursday before the class to take?
One person said he was gonna try to
Okay,
do
I'll
it
come
now.
then.
Okay.
You're gonna be here at 8?
8 o'clock down in my office,
Gotcha.
265.
Thank you.
I just want to make sure one more time.
Okay.
Tomorrow you'll be here from 8 to 4.
Yeah, tomorrow I'm on
Do you have,
Biscayne.
do you have classes?
I have class, I'm free from 8 to 10.
Okay.
I have a class from 10 to 11:40. Then I have basically 30 minutes. And then I have a class from 12:15 until 1:55. And I have another 30-minute break, well, sometimes less than 30-minute break.
I'll probably come in the morning.
Yeah, that would
You're
be
free
great.
8 to 10.
8 to 10 would
Because
be
I'll be
wonderful.
out in the morning.
Right.
Taking the little one to school. Well, thank you.
Surely. Now, I have a student waiting for me, so, oh, man.
My test grade.
What's that?
Test grade.
I can't hear you.
Test grade.
Test what?
Grade.
Oh, your test grade, okay, wait just a second.
And if you couldn't hear me in the hallway, I was saying that I wanted to talk to you about making my new school.
Yeah, I heard that. I thought that's what you were coming up to say now, and I'll say I can't do it right now.
Not right now.
Okay.
Whenever you're free, because I'll be here all day too. 10:30.
I think I just went past you. Yeah. There you go. Okay. Thanks.
Oh, so when will you be free?
I'm sorry,
When will you be free?
when am I free? From now until 11:30, from 12:45 until 3:15.
So you won't be here. You won't be here all day today, would you?
Until 8 o'clock tonight. But I've got class from 3:15 until 8, 7:45.
Okay. So when they get done, you want to start on it, or just
What's
look
that?
at it? When they get done, do you want to just look at it?
Look at what? Oh, your schedule?
Yeah.
I'm not staying here. I've got a student waiting in my office right now. So as soon as I take care of her, then we can do that.
Thanks.
Okay. I just got to get down there to her. Oh man. Okay. Quite a few absences today. Too much turkey. Ooh, I've been recording all this. Let me end this now.